In this video we're going to look at one of the more complex problems that you'll have to solve using compound interest or compound depreciation. We're going to look at an example and work through how we work out how many years it takes an amount to double. So we're going to assume in our example that we've got £10,000 that was invested at 10%, and to see when it doubles its value. So it doubles from £10,000 to £20,000. So let's write this down. So our old amount is 10,000. Our new amount is 20,000, and our percentage increase is 10%. So as a multiplier, that would be 1.1. So let's put all this into this familiar form. We've got old amount times multiplier to the power of the number of years equals new amount. So we've got old amount is 10,000. We're going to multiply that by 1.1 to the power of n, and n is what we're actually looking for. That's the number of years, and that equals 20,000. Now by rearranging this, we can find out that 1.1 to the power of n will equal 20,000 divided by 10,000. So 1.1 would therefore be equal to 2. So now we've got to find out what power is 1.1 raised to get to a number of 2. Now at this stage in maths career we haven't got a short way of doing this, so really you've just got to get your calculator out and start working through multiplying 1.1 by 1.1 by 1.1 and do it until the answer becomes greater than 2. And in fact you could try it a number of ways. I was going to start with 1.1 to the power of 5 on my calculator and see what that gives me. So 1.1 to the power of 5, that gives me 1.61. You can just about see that. So that's not big enough, so let's go for one more. 1.1 to the power of 6, is that any good? Well, that's 1.77, so we're getting close. Try another one. 1.11 to the power of 7, 1.94, so we're getting close. We need it to be greater than 2. So 1.1 to the power of 8 gives us 2.14. So therefore, after 8 years, so when n is 8, 1.1 becomes greater than 2. So what we're looking for in this answer is n being equal to 8. So after 8 years, the original amount has doubled in size. And you can work the other way with depreciation to find where it halves in the value. The only difference this time would be that your multiplier, rather than being more than 1, would be less than 1.